Sony, you are muted. Please, your mic. Anup, can we start?
Yes, sir. Yes, sir. Actually, just we are waiting for a confirmation from Reggie, sir. So meanwhile, Sony sir will start the proceeding.
Sony, unmute your mic. Voice,
Good afternoon, sir. Bala sir, you may start the proceeding, please.
Okay.
He has some issue with his mic.
Okay. Good afternoon to all. At the outset, I welcome you all to this popular talk series arranged in commemoration of India Meteorological Department 150 years celebration. I thank Professor Balaji Ramakrishnan, Director NIOT, for accepting our invitation and delivering this talk. Today he is going to deliver the talk on the observations from ocean, experiences of NIOT. As all we know that ocean part, an important part of the component of weather and climate. If we imagine a triangle, at the vertices of the triangle, land, ocean, atmosphere, all these three things form the triangle, and among them, that energy exchanges are taking place, and weather and climate are nothing but the manifestation of these interactions among these three components. One of the component is the ocean. So we request Professor Balaji Ramakrishnan sir to deliver this lecture. DGM will be joining.
He will be. I mean, we will inform sir once he joins. So,
because it is written as welcome, or shall we proceed further?
Yeah. Yes, sir.
It is written as welcome this one. Okay. So I welcome again to all this lecture series. And before starting, let us please welcome him. Yes. You've taken the bouquet. Okay, you take again. We should. So I request Anup, we can ask for introduction to the speaker. Anup?
Yes, sir. Yes, sir.
Introduce the speaker.
Sure, sir. Thank you so much, sir. And namaskar and good afternoon to all of you. I'm Dr. Anup Misra from IMD New Delhi, and I'm very glad to get an opportunity to introduce our speaker with the audience. We are honored to have Professor Balaji Ramakrishnan with us today. And Dr. Balaji has obtained his PhD in ocean engineering from IIT Madras, and He has assumed the role of Director of NIOT since 2024. And prior to join NIOT, Professor Balaji worked in Department of Civil Engineering from IIT Bombay and as a senior coastal port engineer at from Dubai, UAE. And he has been involved in several major waterfront development projects in the Middle East countries, in India and other Asian countries. His primary area of expertise include port, harbor, marina, coastal infrastructural design and developments. Professor Balaji has published more than 75 research papers in peer-reviewed national and international journals. He has been supervising a number of master's and PhD thesis research work in field of ocean engineering. Professor Balaji has been actively involved in several government and ministry-sponsored research projects from Ministry of Shipping, Ministry of Earth Sciences and DST. He has also been an active consultant for major ports, maritime boards, state government agencies and private companies. He has successfully completed several projects pertaining to coastal and maritime infrastructures in India, Asia and Middle Eastern countries. Professor Balaji has earned many awards. To mention a few, Professor S.P. Sukatme Excellence in Teaching Award in 2024 and Distinguished Alumni Award under Academic and Research category in 2022. Institution of Engineers India awarded him Marine Engineering Prize in 2018 and 2022 and Institution Prize in 2015. Indian Society for Hydraulics honored with him that R.J. Garde Research Award in year 2012 under the category of Young Scientist for Outstanding Contribution in the field of hydraulics and coastal engineering. And Professor Balaji had received Maritime Award in the year 2006 from Ministry of Shipping, Road Transport and Highways, Government of India, for part of his PhD work. And I request all of you to join me in welcoming Professor Balaji. Over to you, sir.
Thank you, Dr. Sure, audible now, right?
Audible?
Yes, sir. Yes, sir. Yes, sir. Audible.
Good afternoon to all of you, those who are here in person and those who are appearing online. And first of all, I would like to congratulate IMD for the successful completion of 150 years, such a massive journey in the field of services to the nation. And now I'm little skeptical to call you as our sister institution because now 150 years, you can't be definitely sister of this 30 years old institution. So I would say probably the great grandfather institution of our ministry. And I really thank, to given an opportunity for us to showcase what we have been doing as a small part in the 30 plus years of time as the institution under the MOES. And I really appreciate the IMD's team to organize this event and also to be on board of the event here in person. Some of them have actually traveled to, listen to us. So again, I would like to thank the IMDs for this wonderful opportunity. Can you go to the slide if it's okay with you? I also appreciate my colleagues, NIOT, who has done a lot of job. As I always mention that I just took over 3 months ago. So the kind of presentation that I'm going to make here is predominantly done by their work, and I'm just, face of this presentation. That's it. Well, 1 hour is probably not sufficient enough to explain what we have been doing and what we have accomplished and what we are thinking of doing in future from NIOT's perspective in terms of the observation of meteorological as well as oceanographic parameters in the open ocean. I'll try to give glimpses of what we have done, what we are doing, and what we are planning to do. Okay, the next slide. So this is a quick overview of what I'm going to talk about in this set of slides. There are about 50-odd slides, but I'll try to complete it in 40 minutes. And somebody should please keep a watch of time and just bang me in case if I exceed or overshoot. I'll walk you through what are we doing spectrum of activities beyond the observation part, and also a couple of quick recent accomplishments that are already available in the social media, but still I would like to share it amongst you and those who are actually appearing online as well in the YouTube channel. Then I'll quickly walk you through the importance why it is really required, to observe the data in in situ conditions. And our role or our mandate from the ministry side or from the government of India, what is being expected from NIOT side. And quickly again, what are the challenges that we face in doing the ocean observations and what we are thinking ahead of time. I mean, in the futuristic, in the future time, we would like to do something really futuristic. And there are some great opportunities that I think we can join hands with IMD and other sister institutions of MOES to predict the weather conditions better in place. Next slide. Like I said before, I would like to acknowledge all the efforts of, there are multiple number of, people are involved in this slide preparation, not just only the slide preparation about the entire work that I'm going to present. Some are actually current employees and some have already retired. So I would start from the so-called multitasking staff that we call the MTS, we call them outsourcing staff, contractual technicians, project staff, and a lot of support from administrative staff as well. Regular scientists who are on roll of the ministry, past directors, sister institutions of MOES. Like I said before, there are multiple institutions we join hands together. Some are requirement from the other side of the MOES institution side, but then it would probably be implemented by us and so on. Ministries, project directorates, officials, and obviously all current and past honorable secretaries of MOES, Government of India too. Next. Yes, the mandate is very clear right from the beginning of this institute's inception stage. You all know that it is established in 1993. We are just 31 years old now. We celebrated our foundation day just last month. The mandate is very clear to us that we are entrusted to develop the reliable indigenous technologies to harness and harvest the living as well as non-living resources in the marine environment. And the statement is very simple, clear, and crystal to all of us right from the beginning. Next. Apart from the campus where we are now seated, we do have some campuses of Chennai and one in Sri Vijayapuram, erstwhile Port Blair in Andaman. And we also have a couple of campuses in Andhra Pradesh, one having a beautiful seafront access. It is actually a drone photograph of our campus in a village called Pamanji, some 3.5 hours journey from here towards north, towards Nellore. And we also have some land in Chittedu, hinterland, and we have some facilities being developed right now. And beyond that, we are also thinking of expanding our wings. Next slide. I proudly say that NIOT has footprint starting from Arctic to Antarctic, and there is no place that we haven't touched in terms of our technological demonstration, or it could be even exploring the opportunities or resources. We have some mooring in Arctic, and we have some exploration stations, of course, as you may be aware, in Antarctic. Of course, there are some sister institutions also involved in this. Predominantly, we focus the Indian Ocean and Arabian Sea and Bay of Bengal because that is of our interest, great interest. Next slide. We have a wide range of activities happening, mostly related to engineering and technological front. We do have services and services to the society. I think one of that is also going to be discussed in this particular presentation at length, ocean observation system and HF radar. And there are a lot of other technological development for the resource explorations, niche technologies. And we also have a keen interest in making a lot of indigenization efforts to attain the Atmanirbhar over the years of time. We also have facilities, so-called infrastructure that NIOT has fleet of vessels for not just only for our own deployment purposes, but also for the sister institutions of MOES again. Next. I'll quickly walk you through the recent happening in the campus. We were very proud to have multiple number of verticals under the Deep Ocean Mission. Government of India's verticals have been entrusted to us. 1, 3, 5, and 6 are the verticals under the deep sea mining and then exploration of the biodiversity. We are also mandated to explore the energy options from the marine renewables. And we are also interested to develop the marine station and so on. You know the numbers, and the idea of actually doing this deep ocean mission is not just only to explore the options of blue economy, but also to develop the capacity in-house in the country with the deep knowledge in the marine engineering front. Next. This is one of the most happening and most sought after by the public and media attention. You are again familiar with the name Matsya 6000. We are talking about the Samudrayan project here. We are doing good now. We are going up as per our schedule almost. Before we wanted to send 3 of our scientists to the water depth of 6,000 meters below the sea surface. We wanted to go in steps. So to begin with, the 500-meter rating manned sub is going to be deployed most likely in middle of next year, 2025. And immediately after the successful of that, we would be obviously sending 3 of our scientists to 6,000 meters by 2026 as well. It's a massive project, multiple number of components, complex integration, all of this actually happening in-house. And the credit goes to largely to all of our scientists working on this. They started from scratch, right from the design, specification, development. Some could be manufactured here, some may be outsourced within the country, domestic, and then some are being fabricated from overseas, but still the design belongs to us completely. Next slide. These two are a very interesting recent accomplishment. Our team has successfully grabbed some samples of polymetallic nodules from the water depth of 1,200 meters at Andaman Seas in the month of September end and October beginning. And just a couple of weeks before, another team of our campus has gone to the Indian Ocean ridges, and they found some interesting hydrothermal vent at the water depth of 4,000 meters. And these are some of the very interesting findings, first of its kind in this region I'm talking about actually. Next slide. Couple of months again, maybe some 40 days ago before, I think we have inaugurated a very unique facility, state-of-the-art facility. It's called Ballast Water Treatment Test Facility. As per the International Maritime Organization, every commercial vessel should have this kind of treatment facility built in-house, and the technology will be tested in this facility. This is located in the village called Pamanji in Andhra Pradesh, and the facility has already been inaugurated by our Secretary MOES, and there are some more infrastructure is also coming up in this location. Next slide. Well, that's all about the recent accomplishment I would like to share, and I'll go to the topic of today's gathering, weather forecasting and what are the challenges ahead. I think this is well known to all of us. The atmosphere is a very dynamical physical system, and obviously its behavior is actually governed by laws of physics. And these laws of physics can always be expressed through a set of mathematical equations. Next slide. But then if you have some kind of in situ observation, the data being directly measured from the actual in situ conditions, then probably it is easy for us to determine the atmospheric state at a given condition. So for example, if you measure the data today morning, maybe we can forecast it till afternoon or maybe till evening, and with a lot of again questions. And again, if the measurements are site specific, then the forecasting is also going to be only in the place where you are interested or where you have been measuring these observations. And in case if you are using the mathematical equations that are following the laws of physics, maybe we can think of estimating the forecasted information like ahead of time, maybe tomorrow's weather conditions. But then the reason why I highlighted the immediate time is that the more and more data set that you have to back these for equations, probably you may not be able to go ahead of time a lot beyond tomorrow's weather conditions. Well, when it comes to forecasting, it is synonymous to the numerical models. There is no other way that forecast without the numerical models. I think the advantage of using the computer facilities and the computer infrastructure being now reaching the skies, it is easy for us actually to utilize this infrastructure to get the forecasting done even for the weather forecasting part. Next slide. Well, numerical models are usually built on top of some fundamental equations. In our case, it is nothing but law of physics, and provided the boundary conditions also being applied. If it is global model, even if it is still it's a global model, still the boundary is limited because we are not modeling the entire universe. We are still modeling only a piece of the universe, and obviously it requires a lot of boundary conditions. So not just only the fundamental equations that could solve the weather forecasting, but with the set of boundary conditions. Next. So in nutshell, it is well known to those who are working in the weather science. There are only 7 basic equations that govern the evolution of the entire atmosphere. Next slide. As simple as like that. It's already being projected here, and you may be wondering, when I said 7, only 5 are there. The first equation is basically taking care of the wind speed in all 3 directions, which means you'll have to add 2 more. So that means 7 equations are already there. Next. Yeah, just in case if you are interested in knowing what are these equations in terms of their definitions, conservation of momentum, well known to all of us. It's also being called as the Reynolds state, or it could be even the Navier-Stokes equations. Mass conservation, continuity equation, and then the equation of the ideal gases, and then law of thermodynamics. All these are very fundamental equations. Some of them could be, that you might have studied during your school days. Then 7 equations, we get basically 7 outputs: temperature, pressure, humidity, density, and the 3 components of the wind. Put together 7 output. So you have 7 equations, 7 unknowns to be estimated. So the case is simple, straightforward. That's what we think, right? But that's not the case. It's not as easy as to estimate these parameters accurately. You may get some numbers out of these equations being solved using any numerical methods, but then those numbers corresponding to the 7 unknowns are may not be the correct answers unless you address all other challenges in terms of the complexities exist in the atmospheric dynamics. Number 1, there are many number of challenges that I can always list out, long list, but then I would like to highlight only a few that may be interested in the gathering here. As we speak winds, it's basically, it's function of, how the advection and convection process happens, and how the pressure gradient force is actually acting on. You can always include the Coriolis effect, and you can always, include the impact of the friction. It could be the land friction, it could be the ocean friction, or it could be even within the layers of the atmosphere, where you have difference in pressure gradient, and there could be friction again happening. And then the turbulent eddies. In all of these are completely not understood by any human being as of now, especially the turbulent eddies. The complexities are so challenging that the modeling of this turbulence is still being approximated even in the advanced so-called model that we have been using in the weather forecasting system, or for that matter, it could be any hydrodynamics event system as well. The turbulence are actually usually modeled with some amount of proxies or some amount of approximations. The approximation stops at a place where we believe that it is enough for me to go away with for the practical reasons or practical purposes. So that's the kind of agreement that we have so far. Otherwise, the turbulence is never being modeled completely in any of these numerical models as such. And then those who are again working in the weather science would be appreciating the second paragraph at the bottom, parameterization, which means, you will have to really calibrate, validate, and then you will have to probably approximate a lot of other physical processes that actually exist in reality, but then it is extremely challenging and difficult to model them as it is in our computer tools. So what we do, we adopt large range of parameterization or large range of approximation in each of these terms. And the terms that I have listed out here are not just limited to the parameterization scheme. There are plenty of other terms also in influence. Solar radiation, the variation over the land and water, absorption, condensation, again turbulence comes here, and then how the soil and soil ocean interactions. And surface roughness, I think this is again a different surface roughness on the land. You may have a cityscape, plain land, forest land, and if you go to the open sea, then it could be land, sea, air, a mixture, and then open sea conditions. In case if we have storms, then again it will have roughness much more than on the normal days and so on. So in all of this, it is almost inseparable to look at individually the land, ocean, and atmospheric interactions. It has to be looked at holistically, without which we may not be able to achieve the actual requirement of what we are really looking at, especially the weather forecasting I'm talking about. So it has to be comprehensive as well. So nothing really can be compromised here, and that's the reason why I think globally it is being well understood long ago, and we started actually integrating the measurements, the so-called observations or in situ data collections from the land, ocean, and even atmospherics being collated, and we try to see it actually holistically. Next slide. Yeah, so like I said before, we have fundamental equations, you have mathematical model, you feed, or probably you can try to solve these equations using any mathematical numerical methods, but then you'll be still having a lot of boundary conditions to be applied. Some boundary conditions are actually completely unknown to us, and some are approximated, and some are known to us. I'll come back to them in a minute. Well, there are three different boundary conditions here. I'm talking about the bottom boundary condition and then the lateral boundary condition in case if you're talking only about a regional model. Let's say, you are interested only in the Indian Ocean region alone, and you are not really, concerned about other parts of the ocean global ocean. Then, we call them as a regional model. Then probably you'll have some kind of a lateral boundary conditions. There will be always the bottom boundary condition as well as the upper boundary conditions and so on. The bottom boundary condition predominantly being influenced by the land and ocean, like I said before again, and then the, like I again mentioned before, the ocean component of the Earth has actually great influence on the atmospheric models, and even in the time scales as well. I think we are going to look at that in the subsequent stage as well. Well, we already started actually adopting a fully coupled model where the ocean, atmosphere, and land interacts, and that we believe that they're better predicting than those of the years that where we have the individual components. And even in the global modelers have accepted that the measurements or the observations in situ data collection can, the measurements all along the globe probably will give us the better prediction than the region specific measurements. And I'll come back to you. Even the region specific measurements also very important for us to better understand what is happening within this basin scale dynamics. Next slide. Next. Yeah, there are a few more complexities just to speak about. Air-sea interaction. I think you all are familiar with the air-sea interface. When the air is blowing on top of the ocean surfaces, there will be some all undulations. You will have some kind of a layers of boundary that is being created at the surface between the interface as well. And you also have the surface roughness of the waves, and at times the wave break not only in the shallow waters but also in the deeper waters. These are the process in which the air and sea basically interact. The spraying of the water particles, aerosols. It is basically a temperature exchanging mechanism by the nature by itself in the shallow waters as well in the deep water. Next. All of the theory that we have seen so far is corresponding to the fair weather. If everything goes on fine, then your 7 equations, you have 7 unknowns. You are wonderfully will predict even the forecasting of the weather conditions tomorrow, and it's all fine. But when it comes to the extreme event like a storm and cyclone, all of these equation goes into toss, and it is very difficult actually to bring them into a generic forecasting system. And we feel these extreme systems individually and case-to-case basis, and there could be no common equation that can probably give a solution for all of the cyclones that are visiting in the tropical region, or it could be hurricanes and tornadoes in the other parts of the globe as well. Next. Well, I think this we have already seen, but when you really wanted to get the weather prediction far ahead of time from now, the longer you go, the poorer the accuracy. That is, everyone is familiar with the concept. But then who is going to help the longer projection? Actually, that is what it is being mentioned here. It is already been proven a fact that the slow moving components of the Earth system, for example, the temperature will actually be slowly by the ocean heat dispersions, are capable of actually giving the long-term predictions in terms of the weather as well as forecasting system. Next. Well, just only land-based information probably will help us only in the subseasonal range. Maybe, I'm sorry, there must be a mistake of the spelling over there. Just maximum of maybe maximum 2 months of time period. But as you are really interested in the long-term prediction, you really have to go for the slow-moving components of their system. And you may be wondering why we need to predict time ahead, so much ahead, seasonal as well as annual and decadal. Those who are working in the agro-meteorological science, they would tell us, it is really important for them to know at least one season before what could be the weather conditions, so that whether they can go ahead with a particular crop pattern or not. These are really essential, parameter for the farmers to decide and also to, to make their agricultural product actually to go up in this, with the scale. Next. This is also well proven. One single pictorial representation of how the observations of the atmosphere alone and just alone land as well as ocean can help us in the forecasting scales. And the y-axis is basically relevance of the initial condition, which means the closest to the junction x-axis it is poorer, and as you go up, it is actually good and excellent. And in the x-axis, you are talking about the forecasting time lead, starting from 0 to days and months and so on. So it is very clear, and it is being already proven, has been proven by various scientists and the researchers in the past, that the measurement longer and more measurements from the open ocean can help us in predicting the weather conditions in the long range ahead of time, but with a little poor quality, and as compared to the atmosphere and just land condition where you can't even predict actually. As we have more and more ocean observation, probably the predictions can go better, but then you need to have more number of in-situ observations for that. Next. And it is also been proven by the science that the measurements as you go down deep in the water depth, from the surface to the deep water depths, the ocean data being collected in terms of the conductivity, temperature, and even the salinity and so on, they can help us, again, predicting the weather conditions in the long term better compared to only the surface measurements alone. So these two factors, I would like to emphasize, because we are going to talk about this in the subsequent stage in the slides later on. So it's very simple. In a nutshell, only the ocean measurement can probably help us forecasting the weather in the long lead time ahead of time, compared to the land as well as atmosphere. Next. I think this is known to us. The weather dynamics are actually varying region to region. Even we are talking about the entire global condition, and it is also basin to basin. If you're talking about the open ocean like Arabian Sea and Bay of Bengal, the atmospheric interactions are going to be different in Arabian Sea as compared to the Bay of Bengal, and even within the basin at times, especially during extreme heat, it will be very interesting to see how within the basin one area is going to be experiencing some extreme weather conditions, whereas the other remain relatively calm comparatively. So the idea is that the observations or the in-situ measurement should be spread across the space and time as optimal point as possible, so that the mathematical modeling probably can actually pick up the information with a great accuracy. On top of what we are already talking about, the climate change, based on the anthropogenic influences, there are a lot of challenges, even in terms of the measurements as well. So we are still working on how to optimize this. Next. This is also a well-known fact, but I would like to bring it to the notice of the others gathering here, that in-situ measurements are always pretty expensive. Although they are the actual ground truth information, provided you use the right sensor and the right electronics information. Once you deploy, it is guaranteed that you get the actual ground truth information. But then it's familiar over spatial and temporal coverage. You cannot really cover the entire open ocean to deploy with many number of observation systems. It's going to be pretty expensive. And even to make the long-term measurements, only our OS team in the NIOT will tell you how much it really costs even to maintain this discrete, isolated measurement that we are actually making, to help the ocean observation going. It incurs massive amount of energy as well. Very interestingly, in situ measurements are actual ground truth, but they don't have any predictive. I mean, they cannot actually forecast immediately by themselves. Next slide. Only numerical model can do. Thanks again to the computer infrastructures that we can probably now cover the spatial and temporal domains fairly well, high resolution. I think models now become very high resolution. They can actually talk about sub-kilometer models in the entire global domain talking about. And very great advantage of these mathematical models are that they can go back in time as well as ahead of time. If you want to really go back and find out, how the particular cyclone actually gone past, you can still do that using the computers. And at the same time, if you want to forecast the weather condition ahead of time, like, how is it going to look like tomorrow, day after, or maybe next week, you can do that as forecasting. So you can travel in time. That's a great advantage of these numerical models. But unfortunately, they are again based on set of equations. There are a huge amount of empiricality, a lot of unknowns. Like I said before, the drag coefficient, friction coefficient, and advection diffusions, all of these are actually completely unknown. So they have to be properly calibrated. Unless you feed those right values, they can always give some kind of a junk in, junk out. So you'll have to be very cautious about that, which means you still need in situ data to trigger them. So you go back to the slide number or inside. So the gap between the in situ and numerical model to great extent can be filled by the remote sensing, thanks to the satellite number of satellites being launched by us, India, as well as the global partners. There are some satellites, as you may be knowing, exclusively meant to observe the weather conditions, in fact, across the globe. So they give great amount of extensive spatial coverage, and they also have great amount of time coverage as well these days. They give near ground truth data, but again, I always, being a, modeler, I also have a question about that. You still they are just pictures, so still you may have to write a specific algorithm to bring the engineering parameters from these pictures. They are nothing but photographs. So from the photographs to the engineering parameters, there are algorithms involved, and these algorithms have to be tested, again validated. Again, you require in situ data. Okay, so those pictures are again converted to the engineering parameters require some kind of in situ observations as well. But they can probably compensate, complement each other. Sorry, not complement each other. And there are some supplement factor as well. And I always believe that all of these tools and the advantages of these individual aspects should be made best use to predict the weather conditions better. Next. Yeah, go back. So we also have some analytical tools, but I think in the weather forecasting, we don't really prefer to use the analytical tools, but there are some probabilistic tools that we have been successfully using. In case if you have a large amount of data, probably you can play with the probabilistic approach, but then predominantly we believe in the physics-based deterministic models that are going to give better results than the probabilistic. And now it is also of the order of the day that we talk about the data-driven artificial intelligence and machine learning. But for them to act properly, work really well, you still require a large amount of data, actual data. Either from the mathematical model, which again validated with the in situ data. So the point here is that the one particular slide alone gives a great amount of emphasis back and again that the actual ground truth data, in situ measurement, the data collected from the field condition is really important actually for us to move ahead. Maybe until up to the point where you feel that I have enough data, now I don't have to go back to the sea or go back to my weather radar station, that I'm good enough now I can actually go ahead with the time. I don't think that will actually ever happen because of the changing climate. That puts us actually back in our backseat, and then square one, we start from the scratch all the time. Every single cyclone basically teaches us the lesson, I think, as we see that in the recent times. So in my view, I think we should judicially use all of these tools available at our disposal to move ahead to observe the weather conditions and forecast as well. Next. Yep. So this is the actual topic of today's presentation, the ocean observation system of our institution, NIOT. Next. Yeah, although we are established in 1993, the ocean observation system, as I understand from our colleagues, that it is started in 1997, and we are the only institution right from the beginning mandated to do the services to the nation. We not only design, develop, integrate, and then deploy, maintain, retrieve, collect the data, and we do all sort of services related to the open ocean observation systems. Next slide, please. Yeah, this is well known to us. There are approaches to different approaches in the ocean observation. One is Eulerian, where you just deploy at one particular point. Although it is not exactly the point, it has the provision to move around, but not so much. We collect the data in one particular place of interest in a particular water depth in the open ocean. And on the other hand, we can also collect data as you go, as you've been drifted by the existing dynamic system of the open ocean. We call it as Lagrangian approach. Next slide. We have three distinct different types of buoying being operated by our team, Met-Ocean, meteorological as well as the oceanographic parameters being measured by our buoys, omni buoys, and tsunami warning buoys as well. Yeah, these buoys again require a very interesting set of moorings because the kind of purpose they are deployed are different, and the kind of measurement that we are expecting from these individual buoys are also different. So their moorings are also different. Now, for example, the Met buoy has many number of sensors being fitted along the mooring line as well. So as I said before, in the early stage, that as you measure the oceanographic parameters deeper towards the seabed, the longer that you can actually predict your weather conditions. These are going to be really useful, and we have been doing that already. And we make the CTD measurements all along the water depth to some extent possible. And the tsunami buoy has a very specific configuration, special configuration, I would say, which is meant to only to give the alarms and warning system, warning during the tsunami, in the end of any tsunami event. Next. We have buoys spread out in the Arabian Sea and Bay of Bengal, and we do have responsibility of actually taking care of them buoys even in the Indian Ocean, but not by us, but by other counterparts elsewhere from globe. Next slide. Yeah, so we predominantly measure the meteorological parameter. They are point-based. We have plenty of sensor fitted on top of these buoys. These buoys are of the order of 2 to 3 meter diameter. Very small buoys will be standalone, anchored, multiple sensors along the mooring line to measure the oceanographic parameters, including the waves and so on, and meteorological parameters, including humidity, pressure, and temperature, and so on. I think these are the parameters which we are really looking forward to be integrated in our mathematical models. Very important as well. Next slide. We do have some coastal buoys. The distinction between the one that we have seen in the previous slide and the one that is being projected right now on the screen are the water depth. Of course, it it matters a lot for us, and these are relatively shallow water depths, and there are some challenges in terms of the design and development. I think that might not be interesting to the gathering here, but they collect interesting parameters that are also of great use to us. Next slide. Yeah, we have been given the mandate of deploying the tsunami buoy ever since the 2004 tsunami, Sumatra tsunami that struck us. Immediately after that, this program has been kickstarted, and we are the sole institution responsible for design and deployment of the tsunami buoys. Few of them are actually monitoring the Bay of Bengal side, and a couple of them on the Arabian Sea side as well. Although we don't have any history of tsunami formation in the Arabian Sea, but we wanted to have some kind of a measurement continuously happening with us. And this is being shared through our sister institution in COIS, and it is also being shared amongst the global partners elsewhere. Next. We help the other institutions. I think we help ISRO for their CalVal. I think this is very interesting project that we do whenever it is being asked by ISRO to do so. Next. Yeah. We have over time into the communication system. I think the data that we get, all the meteorological and open ocean parameters, real time. I think as we speak now in this room, a room dedicated exclusively for real-time monitoring of all these data points, and we get the data as and when we collect it. With a small time lag, I think we were able to get that thanks to the satellite technology. Next slide. The ones that are being developed deployed very close to the coastline, I think we don't need to rely on the satellite, but rather we can actually get it from the GPRS, or sometimes even, we haven't done, but I think we can even do that with RF frequency and so on. Next slide. Yeah, so fair weather, I think if everything is fine, good, I think our buoys basically capture the mid-ocean parameters continuously and they transmit in real time to us and also to INCOIS. And the knowledge and data being disseminated through INCOIS, although we are the custodian of the data collected to check the quality in terms of quality assurance, and quality check is done by us. And then the data is shared to INCOIS and then further disseminated to the public as well as to the other partners. Whereas the extreme events like cyclones concern, we have very interesting and special contribution from our ocean observation system team. Next slide. Ever since we started this floating buoy program since 1997, we have seen many of the cyclone gone past our buoys, and we have captured more or less all the cyclone-based meteorological as well as open ocean oceanographic parameters. And very interestingly, all of these data are extremely useful for understanding the cyclone better. Although there are models which can always help us in getting the trajectory as well as the pressure system definitions, but then these data are actually very crucial and invaluable actually in fine-tuning our models. Next. Number of cyclones. Almost all of the cyclones, in the Bay of Bengal as well as in Arabian Sea, we have huge amount of data sets, wealthy data sets. Next slide. Yeah, next. I personally involved along with my student team in IIT Bombay. So next, we have used the data being measured by NIOT, and these data sets were really useful for us actually to fine tune our mathematical models that govern the trajectory as well as the wind as well as pressure pattern of every single cyclone. Our focus was mostly on the Arabian Sea side because we felt in the past 1 decade of time, the Arabian Sea cyclones are actually more and more of a great concern, equally of the magnitude of the Bay of Bengal, especially the past 1 decade I'm talking about. There are cyclones which we haven't seen in the past before in the historical time frame, and we started actually now getting them along the Arabian Sea. So we wanted to give some special attention to the Arabian Sea. Many publications, previous slide please. Previous slide please. Many publications have come out. I think I would like to highlight only a couple of them. I think you are already familiar. Very severe cyclonic system Oki in November 2017, and we utilized the NIOT's buoy-based data to not only validate the water level and the pressure parameters, but we also have fine-tuned using these parameters. We have fine-tuned even the track, how it is going to end. Although this is actually like a forensic engineering analysis, the event has already gone past. We wanted to revisit that and what would have really happened so that the Oki is behaving like this. Some kind of a forensic analysis that we would like to do just out of curiosity, scientific curiosity. Next slide. Yeah, so but the institute observation shared by NIOT through INCOIS dissemination system portal, we were able to reduce the error in tracking the cyclone trajectory. Basically, we have achieved that. Next slide, please. This is another example. Probably you are quite familiar. One another cyclone in 2019 during the early monsoon stage. Very severe cyclone called Vayu. I think this is one of the most challenging along the Arabian Sea in the recent past. The cyclone, which is supposed to go westerly direction, has actually made a complete U-turn, and the dynamics, which was not being seen by any of the meteorologists in this part of the world. And we wanted to revisit that. And we also wanted to see, and these cyclones are actually very close to the coastline, and many of the observations are not being, covering this region. So the observations are slightly far off from those locations. And probably this kind of exercise basically tells us the fact that our observation system has to be even more high resolution in terms of a spatial coverage. This is what I'm trying to emphasize. This one particular exercise that we have attempted as part of our academic exercise clearly tells us that the buoys are actually far away, so we have not much of data actually to be compared with our mathematical model. On the other hand, because of the cyclone, you have elevated the water levels due to the storm surge, high storm surge along the coastline west coast. There is a massive amount of water being piled up, and then it in fact inundated many of the metropolitan all along the west coast as well. So we tried to compare the data that are actually available from the individual port authorities who are maintaining some tide gauges, but then we don't have the data from the meteorological as well as the oceanographic parameter side to validate our mathematical models here. Yeah, basically this helps us in expanding our future. Next slide. Yeah, maybe you can press next. We also have captured very interestingly multiple cyclones on the East Coast. I think it basically helped us in disseminating knowledge very quickly as and when the cyclones are actually passing through our buoys. And it indeed, we are very proud to claim that it indeed has actually saved a massive catastrophic disaster that could have happened without the forecasting, without the observation that we have deployed all along the Bay of Bengal side. Next slide. Yeah, this is another case of Cyclone Hudhud. I think we again helped the disaster mitigation team well in advance time that the trajectory and all that were we were able to find out pretty well because of the measurement system in place. Thank you. Next slide. Yeah, the appreciation goes long list. Next slide. Appreciation from the media and elsewhere. I think we have a lot of support from various stakeholding public domain. Next slide. So having realized that, we thought I think we should make the existing mode data point to capture the cyclonic event closely in time scale. So which otherwise during the fair weather conditions we have some system of time scale in which these ocean observation being measured. But especially in the event of a cyclone kind of a situation that we wanted to develop a special algorithm that will actually trigger the data buoy into a cyclonic mode, and then it will start collecting the data in a very short time interval rather than the time interval that we do usually during the fair weather time. So we have developed some special algorithm, different versions we have tested, and we have successfully implemented. Next slide, please. Thanks to our team. I think we have fantastic data during one of the cyclones where the algorithm was actually triggered automatically. I mean, this happens automatically. We have some kind of threshold value. Once the threshold value being breached, then the buoy automatically goes into the rapid mode algorithm for cyclone capture. And then the meteorological as well as the open ocean parameters being collected in a very short time interval. It will be disseminated through the communication system to NIOT as well as INCAI. Yeah, we monitor the tsunami-genic earthquake events very closely. Next. We have done this successfully since 2005 onwards. Next slide. Yeah, the system works very simple. We have some kind of a bottom pressure recorder. I think this buoy, as I said before, exclusively meant only to monitor the tsunami events. And if there is an earthquake, can also trigger this, but then the bottom pressure records purpose is actually to see is there any anomaly in the the total pressure column, the water column pressure. Then if there is an anomaly, then it triggers the buoy through the acoustic modem communication, and then the buoy will in turn send the data through satellite to our data centers, both NIOT as well as INCOIS, and simultaneously we start monitoring. And this again also I have got some special algorithm. Once there is a tsunami-genic event, then probably it will go into tsunami mode, and then it will start collecting data every few minutes once, and then it will be continuously communicated. Next slide. We have captured some interesting event, but they are not so great event to be really concerned of, but our system is capable of capturing this. Next. Our team has deployed very interesting set of subsurface buoy in the Arctic region that collects not only the oceanographic parameters, but also some acoustic information that gives great amount of information on how the Arctic ice is actually melting down. I think this is also going to be a great invaluable information for the weather forecasting system, I believe. Next. Yeah, having talked about all the capabilities of our team and NIOT's demonstrations, we do have our own challenges. This particular picture taken by our team, one of the buoys being deployed, and you can see wherever you see the block spots and then the empty hole, we are supposed to have a lot of equipments over there, and then probably the so-called solar panels, if I understand correctly, right? All of this has been taken by somebody. We are facing the vandalism. We also have, of course, challenges by the nature as well. Next slide. Yeah, the man-made challenges are easy to address. We created some kind of awareness program. We walked down to village level along with maritime boards, Navy, port authorities. We educate, make the local fishermen aware of these data are actually collected for the interest of the nation, service of the nation, and so on. To great extent, I think we now minimize the man-made effect. But then the natural challenge is still intact. I think the barnacles that form around our equipment, they also affect the sensors, measurement system, and it's really important for us to get the accurate information. It is not just the data that we are talking about, the data that we are talking about here. So we have some approach. We are working on the materials. We are working on how to avoid these natural challenges. Actually, I think we are slowly moving ahead. Next slide. We have another team exclusively set up high resolution HF radars, high frequency radars. I think we have now 10 sites, if I understand correctly, covering fairly the East Coast, and we have one at Andaman and one we have deployed in the Gulf of Combat as well. And the advantage of the HF radar is that it can give us the surface currents, and there are a huge amount of application that you can see listed out on the right corner of the right side of this slide. This is also very useful for the cyclonic pattern, how the circulation happens. The eddies are actually happening during the cyclone passages. We have very interesting past data of the cyclonic events. And these again will help us in fine-tuning the mathematical models as well. Next slide. Yeah. So we also moving ahead, we now fairly understood the challenges and the requirement of the weather forecasting system. So we started actually working on the Lagrangian system, drifter system, and these are fitted with the inside communication, so we can always get the data as it moves through the satellite to our offices. We also have successfully developed autonomous underwater profiling drifters. These drifters are programmed in a way that they can actually go down on their own, collect the temperature, conductivity, and even the pressure data, and then come back. Once they surface, they can actually communicate the data through satellite to our ground stations. We also are working right now in a variable buoyancy engine based spherical automatic underwater profiling information. Again, these are computer programmed, and with a small size that you can see in the middle of the picture, the glass ball spherical thing. It can also go down on its own thanks to our marine sensor and marine electronics team. And we have already developed this technology up to 2,000 meters of water depth, and probably we are looking forward to go down to even 6,000 meters of water depth. And like I said before, as we go deep, the longer the forecast we can actually do. So this is our ultimate goal, and we are also trying to spread the HF radar all along the west coast as well to cover the entire more than 7,000 kilometers of the coastline. And we are also trying to develop some indigenous, very unique technology, the buoys that actually can be below the surface most of the time. And only if there is a tsunamigenic event, then probably it will actually trigger. It will come out and then relay the data, and then again it can go back to below the surface. So this is very again unique technology that we have already developed, but then we are in the testing stage, and very soon we will be able to deploy that in large scale. And as part of the mission Monsoon, we are also trying to measure the wind profiles in the open ocean. This is one of the very unique and first of its kind in our country, at least, we are trying to do. So far, we have been successful in measuring the wind profile using the lidar on land, but the wind profile in the open ocean is also very important, as I mentioned in the beginning, especially during this the storm event and cyclonic event. How the wind spiraling and also the vertical column of the profile structure is looking like. That is going to help us in the track projections and so on. So we are working on that. But there are interesting challenges when you deploy the lidar on a buoy which is already floating. And as you know, the buoys are actually basically undergoing a lot of motions, right? So the lidar probably will not actually measure the wind profile that you measure in a stationary platform like on land. So they'll be keep moving. So there is a huge amount of engineering challenge that has to be corrected, vetted, confirmed, and then probably it will be disseminated in the years to come. But we already started working on that. In the first phase of the mood lidar buoy, I think we have done some algorithm testing process started in our campus already. Next. Yeah, so that's the end, and I hope I stick to the time. Thank you so much for your patience listening.
Thank you so much, sir, for this thought-provoking talk. Now, floor is open for a few questions. All the participants are requested to unmute themselves and they can ask the questions. Yeah, ma'am, please go ahead.
Thank you, sir. I am Monica from Cyclone Warning Division. I just want to know currently what is the total number of buoys over Bay of Bengal and Arabian Sea?
Any point of time, I think NIOT would like to maintain the order of around 20 buoys put together, both Arabian Sea as well as Bay of Bengal, of the order of 20.
Participants present physically, they are also requested to ask their questions.
You can check the chat box also.
Yes, sir, I'm exploring it.
Sir, this is Amit Bharadwaj from IMD. So I have a question regarding increasing the number of observation in Arabian Sea. Is there any new project going on in which in situ observation are being increased?
Yeah, Dr. Amit, thank you. I think this question was also, I tried to kind of, put it in the public forum during my recent visit to NCMRWF. I think there were also IMD's, scientists were also on board of this event. The optimal number of observation supposed to be suggested by those who are working in the mathematical modeling, basically NWP, the numerical weather for, projection, right? You call that, yeah. So the numerical weather prediction modelers should give us, the optimal locations where, probably you feel better that, if you feel that there are some gaps, the optimal number should be advised by the NWPs.
Sir, I think weather forecasters should also provide the input because most of the time the wind speed during the monsoon time is more over near the Arabian Sea, Gulf of Oman, that side, and we don't have any observational data where we can actually provide the warning for the fishermen, another aspect to verify. We are mostly rely on the ASCAT winds. So if some source of observation near that location is also available, that will be good for us for the verification purpose. I understand
talking about Oman coastline?
Yeah, Gulf of Oman near that line where the low level jet is high intensity winds are blowing there.
Yeah.
So is it possible that either we get our buoys or we can get the international collaboration, we can get the buoys data if it is available there?
Dr. Amit, I think we now started realizing the importance of the measurement system has to be increased in terms of number as well as, right? And every single cyclone probably is actually giving us, teaching us a lesson or two. For example, the one you may be familiar in case if you're working in cyclone, Shaheen. There is a cyclone called Shaheen. I think very interestingly, it was cyclone Gulab or something like that on the Bay of Bengal side. It traveled the entire subcontinent landmass and then it became Shaheen on the other side. I think we were very interestingly were able to do real-time forecasting of the cyclone as well. And you are right. We felt really handicapped that we didn't have enough data to claim our projections are actually correct or not. So, we were doing it on real-time basis. When I was in IIT Bombay, one of my students were actually working on that, and we felt really handicapped. But then, such a similar cyclone did not happen after that. So. What I'm trying to tell you is that we probably can't actually address one particular event, but we should look at holistically that optimal. See, again, I told you, right, the in situ observations are actually pretty expensive in terms of the resources. I'm telling you, I think we allowed to invest huge amount of resources. So unless you optimize, probably we'll end up in getting the same data again and again. So that's the point.
So in the similar context, I have a query. Actually, you have shown a slide where you have mentioned there are two tsunami buoys over Arabian Sea. So any near plan for upgrading it?
No, there are two buoys on the Arabian Sea side. So are we having any plans to upgrade it? Yeah, so the point here from my colleague is that, it is meant only to monitor tsunami and nothing else.
There is a question in chat box by V. Nagaraju. He's asking intensity of cyclone disturbance may increase in future. So he wants to have your comment.
Intensity of,
Intensity of cyclonic disturbance may increase in future, and he has put a question mark. So I think he is asking for your comment on this one.
Yeah, there are, I told you, I think in the beginning again, every cyclone in the recent times already taught us actually a lesson or two, and we are still learning. I know the intensification actually kind of, rather little challenging in the recent times. Very rapid intensification has already been felt by some of the cyclones, but not all of them. So which means we are still learning.
So participants present physically, they can also ask questions if they have. And there is a question by online participants by Menka Gandhi. So how artificial intelligence is being utilized in analyzing oceanographic data?
I am personally no expertise on AI, but my generic answer would be like this. If you claim that you have voluminous data that any machine-based algorithm can actually predict, if you come to that comfort level, until that point of time, I think we should start collecting data. Even artificial intelligence, in my opinion, may fail. In my personal opinion. Yeah, it needs massive amount of data. I don't think we have saturated to that extent, in my personal opinion again.
You pay the most cost.
Hello.
Please go ahead.
Hello. Good evening, sir. First of all, thank you so much, sir, for such a nice and informative talk. Sir, I have an query that regarding that ICON, Indian Coastal Ocean Radar Network. What is the range, up to what range the data can be accurately provided, means obtained from this network?
200 kilometers? The radius is of the order of 200 kilometers we are talking about from the installation point.
And sir, up to what range that accurate data can be obtained from this?
The resolution you are talking about?
No, sir, range. Up to what means?
Already informed. 200 kilometers.
200 kilometers from the coastline.
Okay, so up to 200 kilometer, the accurate data accurate data can be obtained.
At the interval of 6 kilometers, every 6 kilometers.
It's a
Okay.
6 kilometer by 6 kilometer grid we are talking about. One data you will get it. I think it is not high resolution, I would say, but still it maps the 200 kilometer of the ocean surface currents very well.
So like sir, our eastern and western coast, so many S-band radars are also has been installed there. So whether comparative to that, whether these radar network will be beneficial to track the cyclone.
We are comparing with this S-band radar.
S-band radar,
and
which
as
is
well as
having
they are asking
Okay, okay, okay.
I just to supplement, radars will start from some other height, but here in HF radar you can get even surface level data. Normally, you won't get the normal operational data of XCS. Only from some certain height you will get. There is vertical height. Here it is. So maximum storms are wave data, wave period, wave height, wave direction, and wind direction.
Yeah, it's function of the purpose, the requirement basically. So the requirement of HF radar is slightly different, but we are also working on a high resolution coastal radar system also. Very soon we may see that also implemented along the coastline, which will be more high resolution in spatial scale, but the coverage will be of the order of few kilometers only, less than 10 maybe.
Okay, thank you, sir.
Thank you so much, sir. So if no further questions, then I would like to request Dr. S. Balachandran to felicitate our speaker.
One minute.
I think we have some questions.
Photograph that end we are taking. End they will ask to all will unmute the camera. End there is this one.
So we have some questions here in the audience.
Yes. One more question from here, audience.
Yes. First of all, it's a great pleasure to be with my great
Sound the question at the
scientists. Okay.
You want it to constant. Sound it visibility.
No. My name is R. Nalaswamy, a veteran meteorologist, and you may be surprised to see me. I joined in 1973 in IMD, served for 37 years, and I was fortunate to be Indian Meteorological Society secretary for a couple of times. So my connection with meteorology is more than 5 decades. Simultaneously, the connection between NIOT, I was a sister organization right from the beginning. Most of our SARS predecessors were also in contact. Definitely, I'm proud to be a part of it. IMD has gained so much from the services. I vaguely remember that the first MOE signed by NIOT and this one by the predecessor. Not much questions. It is among this one. I personally I gained a lot of information. We'll interact with this one you, and because in a couple of days, the 26th is always December is the memorable day of 2004, and fortunately, unfortunately, we see, and I had the opportunity to visit the places just after 2 days there. Not as an official officer with interest, so. And that connection only, I'm sorry to that's tsunami buoys. How far this is a question from some other scientists. Indications, you are able to locate it. We know that's pretty very well. It is tsunami warning is not so. Any country also lagging. This question was put by one of the ocean scientists from Melbourne. He came and gave a lecture here. He possessed just a small remark that ocean data is not used up to the expectation by the meteorologists. So I just told that we have gotten excellent support from the NIOT like that. So definitely we are using, but we'll further utilize like that. So that which way, that is a tsunami, which way this will be in future will be helpful to us. That's the only one question. A lot of questions of that. Thank you. I don't have to take your time.
Thank you, sir. I'm really glad to see, the veterans like you also join on board of this meeting. Interesting. Thank you, sir. The question very quickly. I think purposes are different here. So the buoy system that we have designed exclusive only to monitor any tsunami event. This is predominantly to prevent any disaster that we had in the past. We have historic history of a 2004 tsunami, and we had massive amount of casualties. And so the purpose is just to address only the tsunami, and there is nothing else. And we also wanted to utilize the resources optimally so that in the event of tsunami, it should be prepared enough. The system, which is standalone, far away from the mainland, should be prepared itself to convey this information. So that's the reason why we don't load any other parameter or any other sensors on the tsunami buoy, and the purpose is only to monitor that. Okay. Whereas our oceanographic other data buoys, mid-ocean data buoys, they are meant to measure the data from the open sea. So and accordingly, I'm talking about from the design perspective, sir. In case if you have to continuously operate these buoys for a long period of time, like a year, you need to design the battery capacity, how much energy should be utilized for each of the warning system, and it has to go to the sleep mode. All of this actually, there are a lot of interesting engineering goes into it actually. So it is driven by the requirements. So I think we are not supposed to compare the tsunami buoy and then the data buoy because we are comparing apples and oranges. The purposes are different. Yes. Thank you.
Hello.
Yes, sir.
No more question, huh?
Sir, yeah, just one information. Actually, DG sir will not be able to join today, so he's engaged with stakeholder meet.
Oh, okay.
So we can move to the felicitation part. So I request Dr. S. Balachandran to felicitate our speaker, and then we'll have a picture with online participants.
Before felicitating, I would, from my side, just wish to thank our Professor Balaji Ramakrishnan for accepting our request. His presentation is very, very concise and precise, covering basic fundamental equation right from the fundamental equations required for atmospheric predictions, their limitations, the parameterization that is going inside, the importance of the in situ observation, as well as the numerical model and remote sensing. Again, come back how to go to the importance of the point observations and difficulties in getting. Science is one thing, implementation of science is another thing. As we know that law is something and the implementation law is difficult. So practical difficulties in maintaining the data, we very sitting in the AC room asking for data is one thing, but practically going there, deploying the buoys and maintaining the buoys, getting the data, and particularly that is the time of when there is a requirement. That time problem will start. These are the practical problems we find that one. So what are the various phases and how during different cyclones, how they have provided important data, as well as ongoing and future activities. Very quite interesting that we have a radar, this LIDAR type of things, wind profile and open seas. So more and more informations are coming up. It is simultaneously the data users. Always we think about the data one side, engineering aspect and the getting the data archive is one aspect, but getting the fruitful information from the data is another aspect. That has to be community. I think meteorological community will be benefited from these type of informations and be ready for the information. So that going to come also, we should keep ready with that one more and more data, and we should give feedback to them. So that is one important thing is we should data users should give feedback to the data generators. Then only that will be in hand. They will that will help the people to further development. With these few words, once again, thank you, sir, for giving this nice lectures. We felicitate him. I, on my behalf and all of you and IMD, we would felicitate Professor. Separate. Okay. Okay, we can shoot.
This or other?
Okay.
Okay.
Yes, hello.
Thank you very much, sir. I request online participants to switch on their camera so that we can have a picture together. Please switch on your camera.
Okay, you want like
Speaker,
this?
you may please click a picture.
Fine.
Please announce all those who are online, they can also switch on their camera.
Thank you all. May I request Dr. Amuda to propose a vote of thanks?
Yeah, vanakkam and good evening to all. It's a privilege and honor for me to thank Professor Balaji Ramakrishnan, Director NIOT, on behalf of India Meteorological Department for his highly informative talk. Like for me, it was like our great grandfather listening to the great grandchild, the achievements of the great grandchild. It was really overwhelming to listen because the technological advancements which NIOT has made, it's really vast. I still remember that footprints booklet, coffee table, which NIOT had released on the Mood Ocean Observation Network. Today morning, I had gone through that booklet just to refresh myself and come here. Thank you, sir, for taking us down the lane. And sir proved to be an excellent professor because I was just pleasantly surprised to see the equations introduced. And then he went on to say how the in situ observations are so important. We also, though there are so many NWP models and etc., but we still believe on the actual observations. That is why we do have the class 1 observatories even now. WMO has recognized our class 1 observatories because they are the ones which give us the backbone data. That way, sir highlighted on the importance of in situ observations. Thank you, sir, for that, such an excellent talk. I then thank our DGM M. Mahapatra ji for initiating this popular series of lectures so that everyone could benefit from the repository of knowledge which many experts have. And it's also available in YouTube so that later on we can hear and assimilate them in our own pace. Thanking our DGMG for making this possible. We thank team at IMD headquarters, Dr. Vijay Soni, Dr. Anu, team ISSD, and all others who have been very helpful in this endeavor. I take this opportunity to thank Dr. Balachandran, Head RMC Chennai, for his support and guidance. Thanking all the esteemed officers of NIOT for your gracious presence. Lata ma'am is not here. She was my PhD external examiner. I thank her and Chana sir, Arul Muttaya, so many others I've been associated with. Thank you all for your presence today here. So the enthusiastic support of Team NIOT for providing all the logistic and technical support is gratefully acknowledged. My thanks in particular to Sri Guru Prasad ji for all the support. Once again, thanking you all, wishing you all in advance a very happy new year.
Thank you very much, ma'am. So that's it for today. And the next talk is on 30th of January. So thank you so much.